Hello viewers, welcome to add-on. In this question we are asked, in a common base configuration, the current amplification factor is 0.9 and the emitter current is 1 milliamperes. So determine the value of base current, and these are the options which are given to us. Okay. So in the common base configuration, the current amplification factor is given as alpha. This is equals to IC, which is the collector current, divided by IE, which is the emitter current. So in this question, the current amplification factor is given to us. So alpha is equals to 0.9 and the emitter current is also given to us, which is equals to 1 milliamperes. Okay. So alpha is equal to 0.9, IC is not given, and IE is equals to 1 milliampere or 1 into 10 to the power minus 3. So IC equals to 1 into 0.9 into 10 to the power minus 3. Okay. So if we perform the calculation, or this is divided by 10. Okay. So this is equals to 9 into 10 to the power minus 4 or 0.9 into 10 to the power minus 3. So this is 0.9 milliamperes. Okay. So the emitter current, this is equals to 1 milliamperes and the collector current, this is equals to 0.9 milliamperes. Now this emitter current, we are asked to find the value of base current, but here we have only founded the emitter current and the collector current value. The emitter current value was already given to us. We have already founded the collector current value. So we need to find the value of base current. So in the transistor, one thing we need to know that this emitter current, this is equals to base current plus collector current. This is one of the fundamental theories in the transistor, because in the transistor, there are three terminals: emitter, base, collector. Emitter is N-type, base is P-type, and collector is N-type. So this is N-type. That means it will provide the electrons. So the emitter will provide the electrons to the base, and the base is P-type, so it has holes. And one thing we need to know, the emitter is highly doped, which we have denoted here by plus sign. Base is lowly doped or lightly doped, and the collector is moderately doped. Okay. So this 4 plus sign signifies that this has a high level of doping. This 1 plus sign signifies it has a low level of doping, and this 2 plus sign signifies it has a moderate level of doping. So the electrons from the emitter terminal will enter into the base terminal, where it will recombine with the holes present in the base terminal, and from the recombination, the base current will arise. Okay. So here we can see the doping is very much low. So the number of the holes present in the base are very much low. So few number of holes only recombine with the electrons. Suppose if 100 electrons are passing, only 5 of the electrons will recombine with the holes, and remaining 95 electrons will pass on to the collector terminal. So this 100 electrons is responsible for the emitter current. This 5 electrons is responsible for the base current. I am denoting here, this is responsible for the base current, this is responsible for emitter current, and this is responsible for collector current. Okay. So we can see here, this emitter current is primarily responsible for the flow of all these two currents, this base current and collector current. So we will say the emitter current is equals to base current plus collector current. Here we have already obtained emitter current is equals to 1 milliampere, which was given to us. Collector current we have obtained, it is 0.9 milliamperes, and IB we have not obtained. So IB is equals to 1 minus 0.9 milliamperes. So it will be equals to 0.1 milliamperes, and the value it will be very low. As we can see here, only 5 number of holes will recombine with the 5 electrons from the 100 electrons which are passed to the base terminal. So due to these 5 electrons, only if we can say 100% electrons are passed, only 5% will recombine with the holes. So this current, the current which is generated due to the recombination, will be very much low, as we can see here, which is 0.1 milliamperes. So in our question, the correct option will be option number B. Thank you.